Hi friends, in this video we are going to see how to apply superposition theorem in a circuit consisting of a combination of dependent and independent sources. So here is the problem. We are supposed to get a current I using superposition theorem. Let's mark all the sources over here first. So we are having over here 2 ampere, 8 ampere and 10 volt independent sources. Okay, and only dependent source is a 4i. If you see carefully, it's a current controlled voltage source. So this is the only dependent source present. So while doing analysis using superposition theorem, we have to highlight on independent sources. One source at a time we have to take, replacing other sources by their internal resistances. So let's start the analysis for this problem. So first of all, we are taking the 2 ampere acting alone. At that time, 8 ampere will be open circuited, 10 volt will be short circuited. So 8 ampere is open circuit, means this entire branch will be removed and 10 volt will be replaced with a wire that is nothing but a short circuit. So let's do that. So 2 ampere is acting alone, 8 ampere will be open circuited and 10 volt will be short circuited. So how the circuit will look like? Circuit will look like this. Remember, we are not touching dependent source at all. So we will get a simple circuit like this. Two resistance, one dependent source, and this current source will be there. Okay, and this is the current I we are supposed to find out. So it's very simple. We are having two loops. So let's mark loop current I1, loop current I2. Let's mark all the voltages because of the currents flowing through the resistor in this manner. So we are ready to apply KVL, but there is a current source between these two loops present, hence we have to write the equation of current source first. So the current source, I will take it out of the circuit with all the currents passing through it. This is I1, this is I2. So if you see carefully, this I2 is matching with the current source direction given. So I2 minus I1 equal to 2. After rearranging, minus I1 plus I2 equal to 2, equation number 1. And second equation we will obtain by applying KVL to supermesh. So let's do that. So application of KVL to supermesh will give us plus minus. Let's start from this voltage source. So it's minus 4i plus minus 3i2 plus minus 2i1 equal to 0. I is that variable which is not given by us, so we need a substitution equation for this. So I is nothing but I2 square clear over here. So what we'll do, wherever there is a small I present, we will replace it with a I2. So by doing so, what I will get, minus 4I2 minus 3I2 minus 2I1 equal to 0. Upon simplifying, we'll get equation minus 2I1 minus 7I2 equal to 0 as equation number 2. Upon solving these two equations, we'll get the values of I1 and I2 as, we'll get I1 as minus 1.5556 ampere and I2 as 0.4444 ampere. We are interested in knowing the current small I, which is nothing but I2. So I can say I, which is same as I2, is 0.4444 ampere. Direction will be downward at the given. This is because of the only one source, so hence it is I dash. We need to find out two more currents because two more sources are waiting. So analysis for 2 ampere is over here. Let's go ahead with the 8 ampere. Now 8 ampere is acting alone. So whenever 8 ampere is acting alone, what you have to do for 2 ampere? 2 ampere will be open circuited, being a current source, and 10 volt. It's a voltage source, so this will be short circuited. So in the original circuit, what we have to do, this will be there, 2 ampere will be open and this will be shorted. So we'll get a circuit like this. So once again, here we are having this current I on which this voltage depends, and two loops are there, I1 and this is I2. Let's mark all the voltages because of the current flowing through resistors. This is for I1, and for I2 we'll have only one drop like this. So let's apply KVL to mesh 1. So let's start from this voltage source, plus minus, minus 4I, plus minus, minus 3I1, minus plus, plus 3I2, plus minus, minus 2I1 equal to 0. We need a substitution equation for small I. So we need a substitution equation for this I. This I is a current flowing through 3 ohm. There are two loop currents flowing through it. One is I1 in downward direction and I2 in upward direction. But the direction given by them is a downward, and downward is matching with the I1. Hence it is I1 minus I2. So wherever there is a I, small I, we will replace with a I1 minus I2. So if I substitute over here, I will get minus 4 I1 minus I2, minus 3I1 minus 2I1 will be minus 5I1 plus 3I2 equal to 0. After simplifying, minus 4I1 plus 4I2 minus 5I1 plus 3I2 equal to 0. Let's write it properly. So minus 4I1 minus 5I1, I will get minus 9I1, 4I2 plus 3I2 7I2 equal to 0, equation number 1. Now current source is present in the loop 2, so I can straight away say I2 is equal to 8 as equation number 2. No need to apply KVL to mesh number 2. Upon solving these two, we will get the values of I1 and I2. We'll get the value of I1 as 6.2222 ampere, and needless to say I2 will be 8 ampere only. What we are supposed to get is the current I. So current I is I1 minus I2. So if I substitute the values of this, I will get I1 minus I2 as minus 1.7778 ampere. Will keep the direction same, that is downward, and this is the current because of second source acting alone, hence I will mark it as I double dash. So analysis for 8 ampere for this circuit is over. Let's go for the analysis of 10 volt now. Now we'll consider 10 volt is acting alone. Now in the original circuit, if we take a 10 volt acting alone, there are two current sources, 2 ampere and 8 ampere left. Being the current sources, we will open circuit it. So this branch and this branch, these two branch will go, we will get a very simple circuit of consisting of a one loop only, like this. Ten volt, 3 ohm, 2 ohm, and the only current controlled voltage source, that is 4I, where I is this. So this is a very simple circuit we'll get. Let's consider the loop current in this direction, which is nothing but I only, having the voltages across 2 ohm and 3 ohm in this manner. So let's apply KVL to this. Okay, whenever we say 10 volt is acting alone, what we have done for the 2 ampere and 8 ampere, 2 ampere and 8 ampere are open circuited. So if I apply KVL to this loop, I will get, let's start from here, minus plus, so it's a 10 plus minus 2I plus minus 4I plus minus 3I equal to 0. So upon simplifying, we will get 9I equal to 10, and we'll get the value of I as 1.1111 ampere. Direction is downward, but this is because of third source, so I triple dash. Now we got three currents because of the three sources, so total effect will be nothing but addition of I dash, I double dash, and I triple dash. So I dash we obtain as 0.4444, I double dash we obtain as minus 1.7778, and finally I triple dash is 1.1111. So if I solve this, I will get the value of I as minus 0.2223 ampere downward direction. Let's make this magnitude positive by changing the current direction. So ultimately total I will be 0.2223 2-3 ampere current will be in upward direction. So this is the final answer. I hope you understood the problem. Thank you.